Hi students, in last class we have discussed about oxo acids of nitrogen. Oxo acids of nitrogen. Oxo acids, hypo nitrous acid, hydronitrous acid, nitric acid, pernitrous acid, pernitric acid, known as oxo acids of nitrogen. Now we are going to discuss about allotropic form of phosphorus. Next elements, allotropic form of phosphorus. What is meaning of allotrope? What is meaning of allotropic? Allotrope. What is meaning of allotrope? Same element exhibit similar chemical property, different physical property known as allotropy. Then carbon exhibit the different type of allotropic form. Then amorphous form, crystalline form. Then another one forms are there, fluorine form. Then sulfur exhibit the different form of allotropy. Monoclinic sulfur, alpha sulfur, prismatic sulfur, then colloidal sulfur. Phosphorus also exhibit the different form of allotropic form. Most common allotropic form of phosphorus is white phosphorus. White phosphorus, then red phosphorus, another one yellow phosphorus. Yellow phosphorus. White phosphorus, red phosphorus, then yellow phosphorus. It is or black phosphorus also there. Black phosphorus. White phosphorus, yellow phosphorus, the red phosphorus, black phosphorus. It is the most common allotropic form of phosphorus. What is meaning of allotrope? Same element exhibit similar chemical property, different physical property known as allotrope. Then phosphorus exhibit the most common allotropic form is white phosphorus, red phosphorus, yellow phosphorus and black phosphorus. In addition to that, another two allotropic form of phosphorus are there, scarlet phosphorus and then violet phosphorus. Now we are going to discuss about mainly consists of white phosphorus, red phosphorus and then yellow phosphorus. What is meaning of white phosphorus? Freshly prepared white phosphorus is colorless and it changes to pale yellow. Freshly prepared white phosphorus is colorless and it can be changes into pale yellow because of due to formation of layer structure of red phosphorus. Layer structure of red phosphorus upon standing. This is known as yellow phosphorus. This is known as yellow phosphorus. So freshly prepared white phosphorus is colorless. Due to formation of pale yellow phosphorus, it changes into pale yellow phosphorus because of formation of layer structure of red phosphorus. Hence, it is called yellow phosphorus. The white phosphorus is characteristic garlic odor. White phosphorus is characteristic garlic odor. Garlic odor. It is a poisonous substance. Poisonous substance. White phosphorus is a poisonous substance. That white phosphorus glow in dark due to oxidation of phosphorus in air. The process known as a phosphorescence. What is meaning of phosphorescence? The phosphorus or especially yellow phosphorus or white phosphorus, the phosphorus glow in dark due to oxidation in air known as phosphorescence. The white phosphorus or yellow phosphorus gas low ignition temperature. Very low. Hence it undergo spontaneous combustion in air to produce the phosphorus pentoxide. Spontaneous combustion in air to produce the phosphorus pentoxide P2O5. It is a characteristic of white phosphorus. Freshly prepared white phosphorus is colorless and it changes into pale yellow phosphorus due to formation of red phosphorus upon standing. Hence it is called yellow phosphorus. The yellow phosphorus is a characteristic garlic odor. It is a poisonous substance. It glow in dark due to oxidation to produce the phosphorescence. The process known as phosphorescence. The yellow phosphorus gas very low ignition temperature. Hence, it undergoes spontaneous combustion in air to produce phosphorus pentoxide. Next one, the white phosphorus. White phosphorus can be changes into red phosphorus. Heated at 420 degrees Celsius. Heated at 420 degrees Celsius, white phosphorus can be changed to red phosphorus in absence of air or oxidizing agent or light. Red phosphorus does not show the phosphorescence. Red phosphorus is not a poisonous nature. Red phosphorus does not then give the garlic water. Then red phosphorus again can be converted into white phosphorus. Red phosphorus again can be converted into white phosphorus, return back to white phosphorus by boiling. In presence of atmospheric air, the red phosphorus of vapor condensed to form of white phosphorus. It is one characteristic of red phosphorus. White phosphorus can be changed to red phosphorus heated to 420 degrees Celsius in absence of air or oxidizing agent or light. In the red phosphorus does not show the phosphorescence, does not give the garlic odor, is not a poisonous substance. It has a high ignition temperature. White phosphorus has a low ignition temperature. That's why the white phosphorus or yellow phosphorus is easily undergo combustion in air to produce phosphorus monoxide. Red phosphorus has a high ignition temperature. That is why it is not easily undergo combustion takes place. In then red phosphorus again converted into white phosphorus by boiling in presence of atmospheric air. The vapor of red phosphorus condenses under water to produce the white phosphorus. Next one. In the phosphorus gas, in the polymeric structure of phosphorus compounds are there. Or phosphorus gas, it is in the layer structure of phosphorus P4s are formed. Because of atomicity of phosphorus is 4. That's why the phosphorus always expressed as a P4. Always expressed as a P4 because of atomicity of phosphorus is a 4. Even 4 phosphorus is linked in the form of layer structure. 4 phosphorus linked in the form of layer structure. So phosphorus is a layer structure. It can be used as a semiconductor. 4 phosphorus atom in the form of then polymeric structure of layer, it gas in the 4 phosphorus atom linked through tetrahedrally. Tetrahedral nature. Phosphorus. It is one form of tetrahedral. That the phosphorus linked with another one tetrahedral nature of phosphorus. Then phosphorus bond. That phosphorus again combined with another tetrahedral nature of phosphorus. Then phosphorus. Then phosphorus linked with another one tetrahedral because of 4 phosphorus atom. 1, 2, 3, 4. 1, 2, 3, 4. Here 1, 2, 3. 4 phosphorus atom have polymeric structure. The 4 phosphorus atom linked through tetrahedral nature. Tetrahedral. It is one type of tetrahedral. Then tetrahedral nature. Unlike nitrogen triple bonded with nitrogen exists to form of nitrogen molecule. It is a more stable because of according to molecular repair theory, bond order increases, bond dissociation energy increases, the molecules are more stable, as you know, more stable. Here, unlike nitrogen, phosphorus triple bonded with phosphorus is less stable than the phosphorus single bond phosphorus. Hence, in phosphorus molecule, all phosphorus atom linked through single bond rather than the tetrahedral. They linked through single bond rather than the triple bonds. So phosphorus single bond phosphorus is more stable than the phosphorus triple bond phosphorus. That's why in all phosphorus molecule or any other compound containing molecules, the phosphorus atom linked through single bond rather than the triple bond. In addition to that, another 2 allotropic form of phosphorus are there. One is a violet phosphorus and one is a scarlet phosphorus. It is a characteristic allotropic form of phosphorus. Again I will say, so what is meaning of allotropic form of phosphorus? Phosphorus exhibit the similar chemical property, different physical property known as allotropic form of phosphorus. Most common allotropic form of phosphorus is white phosphorus, yellow phosphorus and black phosphorus. Here, in the freshly prepared white phosphorus is colorless. It can be changes into pale yellow color due to formation of layer of red phosphorus upon cooling or upon standing. Hence, it is called yellow phosphorus. That yellow phosphorus characteristic garlic water. It is a poisonous substance. It glows in dark due to oxidation known as phosphorescence. Then yellow phosphorus gas, low ignition temperature, that is why it is easily or undergo spontaneous combustion end to produce phosphorus pentoxide. One way. Another one way, white phosphorus can be converted into or changes into red phosphorus heated at 420 degrees Celsius. Heated at 420 degrees Celsius in absence of air or oxidizing agent or light. Red phosphorus does not show the phosphorescence. Red phosphorus in the what? Does not show the garlic water. Red phosphorus is not a poisonous substance. Red phosphorus has high ignition temperature, does not low ignition temperature. It has a high ignition temperature. That's why cannot be easily combustion takes place. Red phosphorus further can be converted into return back to white phosphorus by boiling in presence of atmospheric air. Then in the red phosphorus of vapor condensed to form of white phosphorus. One way. Another one, the phosphorus gas layer structure can be used as a semiconductor. 4 phosphorus atoms have polymeric structure of phosphorus linked through tetrahedral nature. Unlike a nitrogen triple bond nitrogen, phosphorus triple bond phosphorus is less stable than the phosphorus single bond phosphorus. That is why in all compound phosphorus form single bond rather than the triple bond. In addition to that, 2 allotropic forms are there. One is a scarlet phosphorus and one is a violet phosphorus. It is a allotropic form of phosphorus. Next one, we are going to discuss about chemical properties of phosphorus. Chemical properties of phosphorus. Yellow phosphorus is a readily catches fire. Yellow phosphorus readily catches fire in presence of air to produce dense white fumes of phosphorus pentoxide only. Dense white fumes of phosphorus pentoxide. Next one, the red phosphorus do not easily react with the air, is only react with the air upon heating. So phosphorus atom. First one is a react with the air O2. Another one is a reaction with the halogen, especially chlorine. Is a react with the O2, is a react with the halogen. Then is a reaction with the alkali, sodium hydroxide, alkali. Then is a reaction with the concentrated nitric acid, HNO3. Then is a react with the metal, calcium, magnesium, sodium metal. Calcium, magnesium, sodium metal. It is the chemical properties of phosphorus. First one, the phosphorus reaction with the air, O2. Yellow phosphorus readily catches the fire. It gives dense white fumes of phosphorus pentoxide. Yellow phosphorus. Red phosphorus is a react with the air upon heating to produce phosphorus trioxide as well as a phosphorus pentoxide. So phosphorus atom P4, because of atomicity of phosphorus is 4, P4. It's a react with the air O2 to give phosphorus trioxide B2O3 or in then P4O6. P2O3 or P4O6. Both are phosphorus reaction. Next one, in the phosphorus atom P4, it's a band in air to produce phosphorus pentoxide. P2O5 or in the P4O10 phosphorus pentoxide, 5 oxygen. In phosphorus reaction P2O3 or P4O6, phosphorus pentoxide P2O5 or P4O10. So phosphorus band in air. Especially yellow phosphorus readily catches the fire. It gives dense white fumes of phosphorus pentoxide only. But red phosphorus react with air upon heating to produce phosphorus trioxide as well as phosphorus pentoxide. Then phosphorus is a react with air or band in air. Limited supply of air means to produce the phosphorus trioxide. Excess of air means to produce the phosphorus pentoxide. It is a common term of or common reaction of phosphorus in air. Phosphorus react with the limited supply of air to produce phosphorus trioxide. Phosphorus react with the excess of air to produce phosphorus pentoxide. Next one, chlorine Cl2. In the phosphorus atom P4 is a react with the phosphorus molecule P4 is a react with the halogen, especially chlorine Cl2 gives phosphorus trichloride PCl3. Another one, in the P4 phosphorus molecule is react with chlorine Cl2 to produce phosphorus pentachloride PCl5, PCl3 and PCl5. Yellow phosphorus violently react with collagen. Yellow phosphorus violently react with chlorine or collagen to produce phosphorus trichloride. In the red phosphorus react with chlorine in heating. So yellow phosphorus vigorously react with collagen to form a phosphorus trichloride, phosphorus pentachloride. Red phosphorus only on heating with collagen to produce phosphorus trichloride and phosphorus pentachloride. Especially phosphorus react with chlorine to form a phosphorus trichloride and phosphorus pentachloride only. Next one, sodium hydroxide reaction. Sodium hydroxide. In the phosphorus molecule P4, it's a react with sodium hydroxide NaOH in water H2O to produce phosphine PH3 plus sodium hypophosphite NaH2PO2 NaH2PO2 sodium hypophosphite. Phosphorus is reacted to sodium hydroxide in water to produce phosphine and sodium hypophosphite. In this reaction, in presence of atmospheric carbon dioxide or in the hydrogen gas, in this reaction phosphorus acts as a reducing agent. But here, in the, what is the oxidation state of a phosphorus? 0. What is the oxidation state of phosphorus? 0. What is the oxidation state of phosphorus in phosphine? -3, because of phosphorus can be expressed as a X. In then minus and then plus 3 hydrogens are there, because of oxidation state of hydrogen is a +1. How many hydrogen? 3 hydrogen. So plus 3 equal to 0. X which is equal to -3. Phosphorus exhibits the -3 oxidation state in phosphine. In phosphine, phosphorus exhibits the -3 oxidation state. Another one, sodium hypophosphite NaH2PO2. Sodium hypophosphite. What is the oxidation of sodium? +1. What is the oxidation of hydrogen? +1. In here 2 hydrogens are there. So 2 into 1 which is equal to +2. Phosphorus can be expressed as a X. Oxidation state of oxygen is a -2. Here how many oxygens are there? 2 oxygen. So 2 into -2 equal to -4 equal to 0. Because of in this compound there is no charge on there. There is no charge on there. So 1 plus 2 equal to 3 plus x minus 4 equal to 0. X minus 1 equal to 0. X is equal to +1. Oxidation state of phosphorus in sodium hypophosphite is +1. Oxidation state of phosphorus in phosphine is -3. In this reaction, 0 can be converted to -3 one way. 0 can be converted to +1 another one way. 0 can be converted into -3 means oxidation number decreases. The process reduction process. Another one way, 0 oxidation state can be converted into -1. The process oxidation process. 0 can be converted to -3 means in the process reduction process. 0 can be converted to +1 means in the process oxidation process. In this reaction, same element exhibits the increase in oxidation number as well as a decrease in oxidation number known as disproportionation reaction. Don't forget, it is important reaction. In simultaneously both oxidation and reduction takes place in a single reaction, otherwise called a redox reaction. The reaction is called a redox reaction, and then another one ways are there. This reaction, disproportionation reaction. What is the meaning of disproportionation? The reaction which contains same element exhibit increase in oxidation number as well as a decrease in oxidation number. Phosphorus oxidation number 0. 0 can be converted to -3 in phosphine. 0 can be converted to +1 in sodium hypophosphite. That's why phosphorus exhibits the increase in oxidation number as well as a decrease in oxidation number. That is why in this reaction is an example of disproportionation reaction. Don't forget, important reaction. Disproportionation reaction. Next one, phosphorus react with nitric acid, HNO3. Then P4 phosphorus molecule react with concentrated nitric acid, HNO3. Concentrated nitric acid gives in an orthophosphoric acid, H3PO4 plus reduced brown gas of nitrogen dioxide and in the what? Oxygen gas is removed. Nitrogen dioxide and oxygen, water molecule, H2O, water is removed. So phosphorus molecule react with nitric acid, HNO3. And nitric acid is an oxidizing agent. that nitric acid can be converted to orthophosphoric acid, H3PO4, nitrogen dioxide, NO2, and H2 are removed in presence of iodine catalyst, I2, iodine catalyst. In this reaction, catalyzed by iodine. It is important chemical properties of in the phosphorus with oxygen to form of phosphorus reaction, phosphorus pentoxide, chlorine to form of phosphorus trichloride, phosphorus pentachloride. React with sodium hydroxide is follow the disproportionate reaction to form of in the phosphine and sodium hypophosphite. In the phosphorus react with constant nitric acid to form of orthophosphoric acid, nitrogen dioxide, and water molecule. It's a reaction with metal, highly electropositive metals, calcium metal Ca, magnesium metal Mg, sodium metal Na, electropositive metals, alkali metal, alkali earth metal is a highly electropositive metals. The alkali metal, alkali earth metal react with phosphorus P, react with phosphorus to give in the calcium combined with phosphorus to form of calcium phosphide Ca3P2, calcium phosphide. Magnesium react with phosphorus to form of magnesium phosphide Mg3P2, magnesium phosphide. Sodium react with phosphorus to form of sodium phosphide Na3P only, sodium phosphide. Silver metal Ag react with phosphorus to form of silver phosphide Ag3P because of silver plus 1 oxygen state. In the alkyl metal, lithium, sodium, potassium, rubidium, cesium, francium, alkyl metals. The alkyl metal exhibit the plus 1 oxidation state. Phosphorus exhibit the minus 3 oxidation state. That's why formula of sodium phosphide is Na3P. The 3 is a stand for 3 is a valency of phosphorus. How many phosphorus are there? 1 phosphorus. 1 is the valency of sodium. Phosphorus, totally how many phosphorus in silver phosphide? Only 1 phosphorus. That's why valency of silver is plus 1. How many silvers are there? 3 silver. So valency of phosphorus is 3. What is formula of calcium phosphide, magnesium phosphide? Calcium phosphide formula Ca3P2. Magnesium phosphide formula Mg3P2. The 2 is a valency of calcium. 3 is a valency of phosphorus. Here 2 is a valency of magnesium. 3 is the valency of phosphorus. That's why calcium phosphide, metallic phosphide, calcium phosphide Ca3P2, Mg3P2, sodium phosphide Na3P, silver phosphide Ag3P, silver phosphide, sodium phosphide, magnesium phosphide and calcium phosphide. These compounds can be obtained from metal react with phosphorus. The calcium, magnesium, strontium, barium, radium is not vigorously react with phosphorus, but alkali metal, lithium, sodium, potassium, rubidium, cesium, francium vigorously react with phosphorus to form of sodium phosphide and silver phosphide. Next one, phosphide. It means called phosphine. 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 PH3. Phosphine. It is an important hydride of phosphorus. Important hydride of phosphorus. It means called a phosphine. PH3 is a phosphine. Now we are going to discuss about in the preparation physical and chemical properties of a phosphine PH3. So PH3 can be obtained from in the white phosphorus or yellow phosphorus react with sodium hydroxide in presence of inert atmosphere of carbon dioxide or hydrogen. Inert atmosphere of carbon dioxide or hydrogen. So the phosphine can be prepared from phosphorus P4. So react with sodium hydroxide NaOH and water molecule H2O to give phosphine PH3 plus sodium hypophosphite NaH2PO2. NaH2PO2. Already we have discussed about this reaction. Because of this reaction, example of disproportionate reaction. Phosphorus 0 oxygen state can be converted to -3 in phosphine. Phosphorus 0 oxygen state can be converted to +1 in sodium hypophosphite. Same element exhibit the increase in oxidation number as well as decrease in oxidation number known as in the disproportionate reaction. It is an example of one of the important disproportionate reaction. So phosphine PH3 can be prepared from phosphorus react with caustic soda or sodium hydroxide in presence of inert atmosphere of carbon dioxide or hydrogen. From this reaction, the mixture of phosphine PH3 and phosphine dihydride B2H4 is obtained. This reaction is a mixture of phosphine pH3, phosphine dihydride P2H4 is obtained. From this mixture, the phosphine can be separated by the mixture passes through freezing mixture because of in the phosphine dihydride is easily condensed to form of liquid. Then the phosphine maximum exists as a gas. In freezing mixture, the phosphine dihydride is easily condensed to form of liquid. Phosphine is a gas. So in the phosphine can be separated from this mixture of phosphine and phosphine dihydride is a passes through is a freezing mixture. It is one of the important method to preparation of phosphine. Another one, in the hydrolysis of metallic phosphide, calcium phosphide, Ca3P2, calcium phosphide. The calcium phosphide can be prepared from calcium combined with phosphorus. So calcium phosphide hydrolyzed by water H2O or metallic phosphide like aluminum phosphide ALP hydrolyzed by mineral acids. Hydrochloric acid is a mineral acid. Hydrolyzed by water and mineral acids. The calcium phosphide react with water to give calcium hydroxide CaOH twice plus phosphine pH3 is removed. pH3 is removed. Aluminum phosphide react with hydrochloric acid give aluminum chloride AlCl3 plus phosphine pH3 is removed. pH3. It is a one way. So preparation of phosphine from metallic phosphide, aluminum phosphide react with or hydrolyze with water or mineral acids. That means called hydrochloric acids. Another one, pure form of phosphine pH3 can be prepared by decomposition of phosphorus acid H3PO3 phosphorus acid decompose on heating to form of orthophosphoric acid H3PO4 plus phosphine pH3 is removed. So phosphorus acid decompose certain temperature to form of orthophosphoric acid H3PO4 plus phosphine pH3. In this reaction also is an example of disproportionate reaction because of in the phosphorus exhibit the increase in oxidation number as well as a decrease in oxidation number. H3PO3 H3 in then PO3. What is the oxidation of phosphorus in phosphorus acid? What is the oxidation of phosphorus in phosphorus acid? Then hydrogen oxidation of hydrogen plus 1. So 3 hydrogens are there plus 3 plus phosphorus can be expressed as a X. In then 3 oxygens are there. Each oxygen exhibits the minus 2 oxygen state. 3 into 2 equal to 6. X minus 6 equal to 0. There is because of there is no charge on the compound. X minus 3 equal to 0. X is equal to 3. So phosphorus in phosphorus acid exhibits the plus 3 oxygen state. Here plus 3 oxygen state. Next one, orthophosphoric acid H3PO4 H3PO4 3 hydrogen 3 plus phosphorus can be expressed as a X. In the oxygen of oxygen minus 2. 2 into 4 equal to 8 equal to 0. X minus 5 equal to 0. X is equal to plus 5. Here in an orthophosphoric acid contain phosphorus exhibits the plus 5 oxidation state. Plus 5 oxidation state. Phosphine contain a phosphorus exhibit the minus 3 oxidation state. So in the phosphorus acid contain a phosphorus exhibit the plus 3. Phosphoric acid contain a phosphorus exhibit the plus 5. Phosphine contain a phosphorus exhibit the minus 3. Here minus 3 can be converted to plus 5. Oxidation number increases. The process oxidation process. Next one, plus 3 can be changes into minus 3. Oxidation number decreases. The process reduction process. So both reduction as well as oxidation takes place simultaneously in a single reaction known as a redox reaction. This reaction example of redox reaction. Another one, same element exhibit the increase in oxidation number plus 5, decrease in oxidation number minus 3 known as a disproportionate reaction. This reaction also is an example of disproportionate reaction. Important one. It's a preparation of phosphine from phosphorus acid decomposed to form of phosphoric acid and phosphine. Next one. In a sample of pure phosphine can be prepared by phosphonium iodide. PH4I, phosphonium iodide. React with caustic soda. It means called sodium hydroxide. Caustic soda, sodium hydroxide to form phosphine PH3 plus sodium iodide NaI plus H2O phosphine pH3 subtype. These processes are preparation of phosphine. First one, the phosphine can be prepared from phosphorus react with sodium interaction in water in presence of inert atmosphere of carbon dioxide hydrogen. One way. Another one, in the metallic phosphide hydrolyzed in water molecule or in mineral acid. Another one. Next one, phosphorus acid decomposes at a temperature to form of phosphoric acid and phosphine. In this reaction, preparation of pure form of phosphine. Next one, in the sample of pure phosphine can be prepared by the phosphonium iodide react with caustic soda. That means called sodium interaction to produce phosphine, sodium iodide and water molecule. Phosphine, sodium iodide and water. Next one, physical properties. Physical properties. In the phosphine is colorless, poisonous, rotten fish odor. Rotten fish. Ali mean vasani. Rotten fish odor. So phosphine is a colorless substance. Poisonous substance. Rotten fish smell, rotten fish odor. It is a neutral substance. It is slightly soluble in water molecule. It is a neutral substance, that's why it does not show any characteristic litmus changes. If the acidic solution means it can be changed, the blue litmus paper can be changed to red. If the basic substance means it can be changed, in the red litmus paper can be changed into blue. But here phosphine is a what? Neutral substance. The neutral substance does not show any characteristic changes of litmus paper. Heated at 188 Kelvin. Heated at 188 Kelvin. 88 Kelvin. It condenses to form of liquid. The phosphine can be changed into liquid. Heated at 188 Kelvin. Heated at 139.5 Kelvin. It freezes to form of solid. It freezes to form of solid. It is an important physical properties of phosphine. Phosphine is a colorless, poisonous, rotten fish smell. It is slightly soluble in water molecule. It is a neutral substance. Does not show any characteristic property of litmus changes. Heated at 188 Kelvin, it condenses to form of liquid. Heated at 139.5 Kelvin, it freezes to form of solid. It is important physical properties of phosphorus. Next one, chemical properties of phosphorus. Chemical properties. Chemical properties of phosphorus. Chemical properties of phosphorus. First one, thermal stability. Thermal stability. Next one is combined with the air. That means called a combustion process. Combustion. Another one, it is a basic nature, slightly basic nature. Basic property. Basic property. Is react with halogen. With chlorine. React with halogen. With chlorine. Next one, reducing property. Reducing property. The last one, formation of coordination compound. Coordination compound. Formation of coordination compounds. It is a chemical properties of phosphine, not phosphorus. Phosphine pH3. Chemical properties of phosphine. Thermal stability. The phosphine heated in absence of air. Phosphine pH3 heated in absence of air. Heated at 317 Kelvin. Heated at 317 Kelvin to form phosphorus plus hydrogen gas is removed. Phosphorus and hydrogen gas is removed. Next one, combustion. Combustion. The phosphine pH3 is a burn in air. Burn in air to produce phosphorus pentoxide P2O5 or in the P4O10 and water H2O and water. In the phosphorus pentoxide P4O10 hydrolyzed by water to give metaphosphoric acid PO3 plus water. Metaphosphoric acid. What is formula of metaphosphoric acid? HPO3, metaphosphoric acid. Next one, in the basic property. In the phosphine is a slightly basic nature. That's why it's a react with hydrogen acids, hydrogen halogen acids. The phosphine pH3 is a react with hydrogen iodide, Hi, to produce in the phosphonium iodide pH4i, phosphonium iodide. Phosphonium iodide pH4i hydrolyzed by water H2O gives again return back to form of phosphine pH3 plus in the hydronium ion H3O plus I minus, again return back to form of original compounds of phosphine. Next one, reaction with chlorine Cl2, reaction with chlorine. The phosphine pH3 is a react with chlorine Cl2 to form then phosphorus pentachloride P5 and hydrochloric acid is removed. P5 is formed, phosphorus pentachloride. Next one, reducing property of phosphine. The phosphine pH3 is a react with silver nitrate AgNO3, silver nitrate to form silver phosphide Ag3P plus nitric acid removed HNO3, nitric acid is removed, silver phosphide Ag3P plus nitric acid HNO3 is removed. So phosphine react with silver nitrate to give silver phosphide Ag3P plus nitric acid. Another one, in the formation of coordination compound, when is a react with Lewis acid like a boron trichloride PCl3 is a react with phosphine pH3, react with phosphine pH3. Phosphine contain phosphorus possess one lone pair of electron. In boron atom contain one vacant orbital. Boron atom have valence shell, vacant orbital. Phosphine contain excess of one lone pair of electrons. The phosphine donate lone pair of electron to vacant orbital of boron atom to form coordinate covalent bond. So PH3 coordinate covalent bond with boron trichloride. The arrow mark start from the phosphorus. The arrow head end to the in the boron because of boron atom have valence shell vacant orbital. Phosphorus have one excess of lone pair of electron. That's why phosphorus donate lone pair of electron to vacant orbital of boron atom to form of coordinate covalent bond. Coordinate covalent bond of then phosphorus and borons are formed. It is a chemical properties of phosphine: thermal stability, combustion, basic nature or basic property with reactive with chlorine, reducing property, formation of coordination compound, thermal stability. The phosphine heated at 317 Kelvin in absence of air to form of phosphorus and hydrogen or electric spark. The electric spark passes through the phosphorus or phosphine. Another one, combustion. In the phosphine burn in air to produce the phosphorus pentoxide and water. That phosphorus pentoxide dissolved in water to form of metaphosphoric acid. HPO3, metaphosphoric acid, HPO3 and H2O is removed. Next one, in the basic property. Phosphine is a slightly basic nature. Slightly basic nature. Is a react with hydrogen halogen acids, hydroiodic acids. So phosphine react with hydroiodic acid to produce phosphonium iodide, PH4i, phosphonium iodide. Then phosphonium iodide again hydrolyzed by water to give phosphine hydronium ion and I minus ions. Phosphine hydronium ion and I minus ion. Next one, phosphine react with chlorine to form of phosphorus pentachloride and hydrogen chloride. It is an important compound, phosphorus pentachloride. Next one, reducing property. Phosphine react with silver nitrate to form a silver phosphide and nitric acid. In this reaction is not a reducing property. Next class I will say the reducing property of a phosphine, phosphorus acid and in the what? Hypophosphorus acid, then tetraphosphoric acid. Next class I will say. In the next one, formation of coordination compound, boron trichloride react with phosphine to form of in then phosphine and boron trichloride in between the phosphorus and boron to form a coordinate covalent bond because of the boron trichloride act as a Lewis acid, in the phosphine act as a Lewis base. So phosphine act as a Lewis base, boron trichloride act as a Lewis acid. Then boron trichloride contain a boron have vacant orbitals are there. Phosphine contain a phosphorus possess one excess of lone pair of electron. That is why here phosphorus donate lone pair of electron to electron deficient species of boron atom to form of coordinate covalent bond formed between phosphorus in phosphine and boron in boron trichloride. It is a chemical properties of either what? Phosphine. Next one, structure of the phosphine. Structure of phosphine. In the phosphine exists as a pyramidal shape. The phosphine exists as a pyramidal shape. Phosphorus, totally how many lone pair of electrons are there? Only one lone pair of electron. Even totally how many unpaired electrons are there? 3 unpaired electron. 1, 2, 3. 3 unpaired electron. The 3 unpaired electron utilize in the formation of 3 covalent bond with 3 hydrogen atom. Hydrogen. These are 2 unpaired electrons share to form a 1 covalent bond. These are 2 unpaired electrons share to form a 1 covalent bond. These are 2 unpaired electrons share to form a 1 covalent bond. So phosphorus has 3 unpaired electrons. Each hydrogen atom have 1 unpaired electron. 3 unpaired electron utilize the formation of 3 covalent bond with 3 hydrogen atom. One of the lone pair of electron occupy the tetrahedral position. This is a phosphine, it become a pyramidal shape. The phosphine, it become pyramidal shape. Phosphorus, hydrogen, then hydrogen, phosphorus, hydrogen. The bond angle is 93.5 degree. Phosphorus and hydrogen, bond length 1.42 Armstrong. So, one of the lone pair of electron occupy the tetrahedral position. 3 unpaired electron utilize the formation of 3 covalent bond. The phosphine it become a pyramidal shape. Hydrogen, phosphorus, hydrogen bond angle 93.5 degree. Phosphorus hydrogen bond length 1.42 Armstrong. Actually, in tetrahedral bond angle 108.9 degree. Here, the bond angle, original bond angle of 109.28 meters can be reduced to 93.5 degree because of here lone pair bond pair repulsion increases. Due to lone pair bond pair repulsion, the bond angle reduced to 93.5 degree. That means got 94 degree. Okay. Okay students, today topic over. Next topic we will meet the next video. Thank you.